Welcome, geometry students, to class today on Tuesday the 29th. Let me go over some announcements and address a couple of things that need to be addressed, and then we'll go from there. First of all, we will have a test next Tuesday and Wednesday. Let's talk about this. Sometimes I have to mention your names, sometimes I don't have to. In this case, I don't need to mention a student's name, but a student yesterday wrote me a note. And by the way, it'd be really helpful if each of you emailed me. I know you've done it in the past, so it's my fault. I did not save your emails, and that's totally my fault. But if each of you would email me and just say hi, or here you go, or something like that, I could then record all of your emails in my address book. I should have done that, and I did not. And then I can correspond with you when you email me or write notes on top of your homework or test or whatever. One of you, and you know who you are, you wrote me a note yesterday on top of your homework, and I've been considering doing this, and I'm going to go ahead and do it. And this will kind of go along with that note. The student said, I'm struggling with the memorization part on the test. What can I do? You know, I want my grade to go up. And I get all of that. And of course, I've told you 100 times, I'm here to help you. I will say this about geometry. Geometry is a little weird. It's not like in algebra where you can say we're going to have a section on quadratic equations, a section on linear equations, a section on graphing. In geometry, they'll take a theorem or a postulate or a corollary or a definition, and they might give you 1, 2, or 3 or 4 different problems about that theorem or about that corollary. And the problem for a teacher is it's not like algebra where I can give you examples of the problems that will be on the test. Instead, I have to give you topics, and any geometry teacher will tell you this unless they're really teaching to the test and just giving you exact problems they give you in class, and that's not really geometry, guys, okay? I'm not being mean, but it's not, okay? Geometry teachers have to tell you what topics will be on the test and then give you a big review sheet like I do that covers all the topics, and then hopefully you're getting the big picture and you can apply, hopefully then you can apply that big picture to different types of problems. So I think since this is a track 2 math class, which does not mean you guys aren't smart, it means that you struggle in math is all that means. I struggled in science and I struggled in history when I was in high school. So I understand these things that you're struggling with. I think I'm going to start breaking the test up into 2 days. Now what that will do is it will allow you to, like Tuesday is going to be the fill in the blanks. Now before you get too excited, I'm not going to give you a fill in the blank test on Tuesday with nothing else. No way, okay? That'll be a day you'll come in and you'll do your fill in the blanks, and then you'll work on the review sheet for the test on Wednesday, okay? But we're going to do that this coming week. So first of all, I think that will help you students that are struggling with your fill in the blanks. Now, it's not a cure-all. It's not going to fix everything. And so if you're thinking, you know, big deal, Mr. Earhart, I know it's not perfect, but it's a step in the right direction. So next week, we're going to have a test on Tuesday and Wednesday. Having said that, excuse me, sorry. Having said that, that will allow you Monday night to go home and focus on your 8, 10, 12, 13 theorems, postulates, corollaries, definitions, whatever it might be that you have to memorize really well so that you can fill in the blanks. I think that will be a help. That's step 1 in the right direction. Let's see how that goes, okay? So next week you will have a test on Tuesday and Wednesday. By the way, it's not 2 tests. I will take these and make them one big test and grade them and give you 1 grade, okay? So something new we're trying, I think, will help you. Maybe you need to turn in your homework, okay? Now remember, this is the homework I gave you Monday in class. I told you it's not due until Wednesday, so don't panic if it's not done. I know one of you 4 turned it in yesterday, and I already recorded that. It's on, I already recorded it, and we're good, okay? The other 3 of you can turn it in now if you did it last night, or you can turn it in tomorrow because there's no homework tonight. Okay? Hope I'm making sense on this, all right? Now, Jasa, I messed up. I was going to say is I'm sorry. I wish I could back up time because maybe you wouldn't have studied so much last night and stressed out. But I'm not going to make you take the quiz today if you don't like to because you were absent Friday. And that's just 2 days ago. And anytime a student misses 1 or 2 days before a quiz or a test, I don't make them take it if they don't want to. Now, you might want to. You can try it. Why don't we do this, Jasa? Take the quiz today if you want to. I should have it graded by tomorrow, the next day. Hopefully, Lord willing, I'll try to do that. And then if you don't do well, we just won't count it. But if you don't do well on this quiz, or if you don't take it at all, either way, you must make it up by Friday. Okay, so keep that in mind. That gives you plenty of time. That's a whole week. And then lastly, now listen to me carefully. When we're done going, now listen to me carefully, guys. When we're done going over your quiz in a second, and by the way, the quiz is going to be out of your book. We'll get that in a second. But when you're done going over your quiz, when you're done taking your quiz, you can go back to this video. This is the video you're watching right now. You're watching Geometry Announcements, October 29th, okay? Well, in a little bit here, I'm going to ask you to stop the video and take your quiz. When you're done taking your quiz today, you can then get out your tests, which, by the way, if papers were not passed out to you today, you might want to pause the video right now and raise your hand and ask the supervising teacher where your papers are, because my son brought those in for you today in a folder, and you should have those today, okay? So, anyway, so I'm going to continue on like you have those. If you don't, pause the video, find out where they're at. But when you're done taking your quiz, and only when you're done taking your quiz today, and after you've turned your quiz in, and only after you've turned your quiz in, you then can go ahead and restart this video and go over the test. You need to do that. You need to find your mistakes. If you don't, you're not learning where you're weak. We're going to have a semester exam at the end of the semester. You need to know where your mistakes were on your test. I'm one of the few, if not only, teachers at Berean that give that I'm a teacher that gives you your tests back and lets you keep them, because I make new tests every year. And I'm not bragging, but I do that for you so that you can have your tests, look at your tests, find your mistakes, and get better as a student. So I hope you will do that. Okay, now I'm not going to make you turn in the problems you missed and redo those. That's up to you, okay? But one thing I don't want is you sitting around the class and doing nothing, okay? So when you're done with your quiz and you've turned it in, then go ahead and restart this video or fast forward it to wherever you were, and the rest of this video will be about the test. And by the way, if the quiz takes you the whole hour and you want to go home tonight and find your mistakes on your test, then here's the video right here. This is the one you're watching right now. You can watch it tonight at your house if you need to. Okay, now here's what I need you to do. Let's go over your quiz. I need you to do the following. Listen to me carefully. I need you to get out your books. It can be an open book quiz. I don't care. You're welcome to leave you're welcome to look through your books, look at previous problems. I don't think it's going to help you a whole lot, because nothing on the quiz is fill in the blank. So go ahead and get your books out, because the quiz is out of your book today. If you'll glance ahead here, it's on these pages here. So go ahead and get out your book, get out your calculators, get out your pencils, get out a blank sheet of paper, and here's your quiz. Okay? Here's your quiz. Now, we're going to go over it in a second. So you'll probably want to pause the video, get out your books, get out your paper, get out your pencil, and I guess you'll need your calculator. I'm not sure if you do actually, but get your calculator out just in case you do. Okay? And then after you've done that, then go ahead and restart the video. Okay? So I'm going to go ahead and go over the quiz now, get these pause the video, get these things out, and then go ahead and restart the video. Okay? All right, let's go over the quiz together. Remember, students, anything that I say now, you're welcome to write down. I have no problem with that. So let's take a look at page 200, and what page was it? Page 249. We're doing numbers 1 through 8 at the bottom. Page 249, numbers 1 through 8 at the bottom, and it should look like this. So if you're not seeing this, you're on the wrong page or you're doing the wrong problems. Okay, first of all, numbers 1 through 4. In the diagram, ABC is congruent to QPR. Complete the statement with the corresponding congruent part. Now, what they're saying is this. Please listen. Write down whatever I say. Feel free to. Notice in the directions it says ABC is congruent to triangle, I think it's QPR. Yes, QPR. So looking at this, you should be able to tell what angle corresponds with what angle and what side corresponds with what side. We've been over this, okay? So you should be able to put in this blank. By the way, these white blobs here are just me covering up the answers, okay? Because the answers are in my book, so I had to cover them up. But angle R right here, angle R is congruent to an angle over here. Put it, write that on your sheet of paper. Put down, number 1, angle R is congruent to angle question mark, whatever you think it is, okay? And number 2, side AB, right here, this side right here is congruent to a side over here. Triangle BAC, now look what they want you to do here, guys, look. Triangle BAC is congruent to, number 3, it's going to be a triangle, triangle blank, blank, blank. You got to get your 3 letters right over here for number 3. If it's BAC, then you've got to know whether Q comes first or P or R, and whether Q, P, or R goes here or Q, P, or R goes here. Number 4, same thing. Triangle RPQ, is congruent to triangle blank, blank, blank. So you've got to know whether A comes first or B or C, or A, B, or C here, or A, B, or C here. And we've gone over all of that, students, really well. I'm not bragging, but we really have covered that a lot, okay? So there you go. That's numbers 1 through 4. All right, number 5, write a congruent statement for the congruent triangles. Now look, all that means is you're going to put triangle, and I really don't. You're going to say EFG if you want to. I don't care. Is congruent to triangle and then blank, blank, blank. And whatever you put here, Z or Y or X or Z or Y or X or Z or Y or X, it better line up with whatever letters you put over here. Now you might have put FEG over here. I don't care, you know, what triangle you put here, but then you're going to write congruent to and then make sure your triangle lines up correctly corresponding, okay? Hope that makes sense. We've been over that, and I told you that would be on your quiz. All right, number 6, 7, and 8. And then we're done with this page. The directions for 6, 7, and 8 say, now listen to me, decide whether enough information is given to show that the triangles are congruent. Now look, if there's not enough information for 6, 7, or 8, then you put no, okay? If there is enough information for number 6 or 7 or 8, then you've got to tell me why. You've either got to say side, 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 angle, side. You're welcome to write these down if you want to. Angle, side, angle, 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 side, or hypotenuse, leg, okay? If you say no, then you're done, fine. But if you say yes, then you better tell me why the triangles are congruent. It's got to be one of these reasons, okay? You might have to, like number 7, I would encourage you to split the triangles up, like I've done for you, okay? So I hope this makes sense. You should know this, okay? Actually, I'm going to go ahead and put that back up again for you so you can take a minute and copy that down if you want to. So these are your reasons you're going to use. Now again, if you put no for number 8, no, we cannot prove that these triangles are congruent, then you're done. That's good. That's your answer. But if you put yes on any of these, you've got to give me one of these reasons right here, okay? All right, go ahead and turn in your books now to the other page, which I think was page 263, if I remember correctly, page 263, and let's look at 5 through 10. Now 5 through 10, if you'll look at the directions, and if I'm going too fast, just pause the video. 5 through 10, the directions say tell, it's the exact same thing. It's the exact same thing that we did right back here on 6, 7, and 8. It's the exact same thing. You're going to tell whether there's enough information to state that the triangles are congruent, and if so, then tell me why. So you're either going to put yes or no for 5, 6, 7, 8, 9, 10. Yes, I definitely know for sure. Yes, I know these triangles are congruent, and if you put yes, then tell me why. Side, 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 angle, 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 side, or hypotenuse leg. Remember, hypotenuse leg only works on a right triangle. Hypotenuse leg only works on a right triangle. And if you say no to one of these, like, I don't know, let's say number 5, you say no, I cannot say for sure they're congruent, then you're done. But if you say yes to one of these, like number 6, then tell me why. You know, side, 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 angle, 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 side, hypotenuse leg, whatever. But you've got to tell me why you have said that the triangles are congruent. So that's your quiz. I do not think it will take you the whole hour. I don't think it will take you much time at all. And now listen to me carefully. When you're done with your quiz and you've turned it in, then, and please don't cheat. Don't try to go back and watch other videos. In fact, I'm going to tell you right now, I'm going to tell Mr. Harmon in the email that I sent him, when you start your quiz, your computer should be shut, okay, or turned off, or no videos. There's no need to watch a video while you're taking the quiz, okay? But now that I've gone over the quiz, and hopefully you've written down everything you need to write down. If not, back it up and listen to this again. But when you're all ready to take the quiz, shut your computer lid or do something or whatever and start taking your quiz. After you turn your quiz in to Mr. Harmon or whoever the supervising teacher is, then go ahead and turn the video back on and go over your test. Okay? All right. Okay, hopefully you did well on your quiz today. Let's go over your test. You should know by now I do not go over the fill in the blanks. There's a fine line between helping students and helping them a little too much and encouraging them to be lazy. You have all of those in your notes. All of the postulates, corollaries, theorems, definitions, they go right in order. I go right through the videos and I cut and paste those from lesson 4.1 all the way into the end from chapter 4. So you can look those up on your own, okay? Now, let's look at numbers 13, 14, and 15. You've got to learn to do this. It says classify the triangles by their sides. When we talk about the sides, then we're dealing with scalene, equilateral. I know I'm being sloppy, but equilateral, or what's the other one? Oh my goodness. Scalene, isosceles. Okay? Now those are the three ways that we classify triangles by their sides. Some of you put right triangle, obtuse. Students, that's when you classify triangles by their angles. Angles would be right triangle, obtuse triangle, acute triangle, equiangular, keyword angular, thus we're classifying it by its angles, angular, okay? These are the four you would use for classifying triangles by their angles. These are the three you would use for classifying triangles by their sides. So here, number 13, none of the sides are congruent. We have three different measurements, so we call that a scalene triangle. Here, all three sides are the same. We call that an equilateral triangle. Here, all three sides are different, so we call that a scalene. Well, Mr. Earhart, what's an obtuse triangle? An obtuse triangle is when you have two congruent sides. Let's pretend this 6 right here would have been an 8. Then we have this side and this side congruent. At least two sides are congruent, so we call that an isosceles triangle. Okay? So a scalene triangle, none of the sides are congruent. Isosceles, two sides are congruent. Equilateral, all three sides are congruent. Now let's come down here to number 16. Notice I marked all three angles congruent. Okay, now we're classifying the triangles based on their angles. So we're going to have to use right, or obtuse, or acute, or equiangular. Well, when all three angles are congruent, we call that equiangular. Okay? Now, you look at number 17. Mr. Earhart, you only gave us one angle. True. But the definition of an obtuse triangle is when one angle in a triangle is larger than 90. And so here's 100. It's larger than 90. So we know right away we have an obtuse triangle. Now, some of you put right triangle for this, guys. And you did that because this looked like a right angle. I didn't try to trick you to hurt you, but I did try to trick you to make you think. Guys, you know that all three angles have to add up to 180. You know that. And so if you take 70 plus 25, you get 95. So this angle here has to be 85. If you add up 25, 70, and 85, you will get 180. So now we know all three angles. Okay? So if we know all three angles, notice all of them are less than 90. Less than 90, less than 90, less than 90. The definition of an acute triangle is when all three angles are less than 90. Okay? Just trying to get you to think, okay? All right, numbers 19 through 21. Find the measure of angle 1. Now, 19 should have been pretty easy for you. We have 28 plus 73. That's 101 degrees. Okay? So if we take 101 and subtract it from 180, 180 minus 101, we get 79 degrees. So we know that this angle right here had to be 79 degrees, because if you take 79 plus 73 plus 28, you will get 180 degrees. Now this one here was probably tough, but come on guys, remember I want you to think. Now can I show you something, please? Watch this. Look, a straight line always equals 180 degrees. We've been over that and over that, okay? Whenever you have a straight line and a line coming off of it, we'll call this angle 1 and we'll call this angle 2. Those two angles, angle 1 and 2, add up to 180. So notice how I have a straight line here and a line coming off of it. Do you see that? So I know this angle here with an X and this angle here have to add up to 180. Well, if this is 132, then I'm going to take 180 minus 132 and I will get 48 degrees. So now I know this angle is 48. And you're like, well, big deal, Mr. Art. You told us to find the measure of angle 1. True. But now look at your triangle. You know, inside the triangle, you have this angle, and this angle. So you know those three angles inside the triangle have to add up to 180. Okay? So if those three angles inside the triangle have to add up to 180, then I have 57 plus 48, 5 carry your 1, 105. And of course, if you take 180 minus 105, you will get 75 degrees. So angle 1 right here had to be 75 degrees. And you might say, well, why is that? Because 75 plus 57 plus 48 is 180. Now, this was a tough problem. I will not deny that, okay? This is a pretty tough problem. But guys, again, I want you to learn to think. And really, I mean, we should be pretty familiar with the fact that a straight line with a ray coming off of it or line coming off of it, those two angles are always going to equal 180. So if this is 125 and I subtract that from 180, I will get 55 degrees. Because 55 degrees, here's a straight line with a line coming off of it, 125 plus 55 degrees is 180. Okay, Mr. Earhart, I get that. You've said that 100 times. Fine. How does that help? Well, here's what I was trying to teach you, or not teach you, but test you on. In Chapter 4, we learned that whenever two sides in a triangle are congruent, like this side and this side are congruent, we learned their opposite angles are congruent. So I can go straight across and go straight across, and I know those two angles are congruent. Now, that's a theorem that we learned, or a postulate, I'm not sure which. It said when two sides of a triangle are congruent, their opposite angles are congruent. So if this is 55, and I went straight across, then that means this angle over here also has to be 55 degrees. And now you should see what to do, do you not? I know that all three angles inside of a triangle, 1, 2, 3, have to add up to 180. So 55 plus 55 would be 110. And then if I take 180 and subtract 110, I will get 70. So this top angle here is 70. So 70 degrees. Okay? All right. Now let's continue on. This was a tough problem. But guys, I'm trying to get you to think. Look, do you see how this side here is congruent to this side here? Do you see that? And remember what we learned, whenever two sides are congruent, their opposite angles are congruent. So that means this angle here is congruent to this angle here. Okay? And some of you on the test are getting angles and sides confused. A side is a measurement of a length, how long a side is. An angle is how wide the opening is right here between two sides, right here. Now look, if these two sides are congruent, then their opposite angles are congruent. So if this is 2x, what does that mean this angle here is? You got it, 2x. And now look, if this is 2x and this is 2x and this is 6x, when you add up all three angles inside of a triangle, what does it always equal? 180. So 2x plus 2x plus 6x equals 180. 2x plus 2x plus 6x is 10x. And now we're going to divide by 10, and x equals 18. So I know you guys, I had you in algebra, in bridge math. I know you guys can solve equations like this like nobody's business, but you've got to learn to set these things up, and that's probably where most of you are struggling. So let me go over this again very quickly. Students, as soon as I saw this side was congruent to this side, then right away you got to realize this angle here is congruent to this angle here. So if this angle is 2x, this angle is 2x. And then your three angles are 2x, 2x, and 6x. Add them together and they equal 180. Now, let's take a look at number 23. Number 23. Look, we also learned that when two sides are congruent, their opposite angles are congruent. We also learned that when two angles are congruent, this is a theorem or a postulate that we learned. Whenever two angles are congruent, their opposite sides are congruent. So that means that side there is congruent to that side there. Let's go over that again. If two angles are congruent, and I marked them congruent for you, then their opposite sides are congruent. So x plus 12 is one side. That has to equal the other side, which is 30. So simply bring the 12 over and make it a negative 12, and x equals 18. So the answer is 18. Okay? Moving on to number 24 and 25. Now this, you shouldn't have missed it. It's Pythagorean's theorem, guys. L squared plus L squared equals 8 squared. So one leg is 4, the other leg is 5, and we're going to find the hypotenuse. So 4 squared is 16, 5 squared is 25. 16 plus 25 equals 8 squared. Add those together, you get 41 equals 8 squared. And now take the square root of both sides, and 41 equals 8. So square root of 41 equals 8, okay? Not mad, not being mean, but we did that in bridge math, and I know when I taught at Berean 2 years ago, we did it in 8th grade math. I know you guys have had this for a couple of years for sure, but whenever you're missing one side in a right, let me get a drink of water here real quick. Whenever you're missing one side in a right triangle, use Pythagorean's theorem, okay? All right, let's quickly use Pythagorean's theorem over here. L squared plus L squared equals H squared. Now one of your legs is X, the other leg is 8, the hypotenuse is 17, all right? Now 8 times 8 is 64. I do not have a calculator with me, so please bear with me. 17 times 17 would be 119.17. I'm getting 289. Excuse me. My daughter's here. Jessica, please check that. What's 17 times 17, please? Thank you. If you have a calculator somewhere. Thanks. We're going to continue on, assuming that I'm right. So if we square 17, we get 289. If we square 8, we get 64. Now bring the 64 over, and when you do, it becomes a negative 64. I'm sorry, Jess. Okay, good, we're right. So bring the 64 over and make it a negative 64, and we're left with 225. 225. Now when you take the square root of 225, I believe you get 15. So take the square root of x squared, you get x. Square root of 25, you get 15. And so the answer is 15. Okay? All right, let's continue on. I asked you to find the distance between 2 points. Right here, there's a distance formula you really should have known, guys. It's x minus x, quantity squared, plus y minus y, quantity squared. Okay? So let's go with x minus x. Here's an x, here's a y. Here's an x, here's a y. X minus x. Now you can use a calculator if you need to. It's 2 minus a negative 4. So 2 minus a negative 4 squared, plus, and then y minus y. So negative 1 minus a negative 6. Negative 1 minus a negative 6. Now, I had you all a couple years ago. You know I'm pretty calm. I don't get mad hardly ever. I just feel bad for it if you didn't get this, because it's just pretty much a calculator problem. I mean, 2 minus a negative 4, that's plus 4, that's 6. If you square 6, you get 36. Let me go over that again. 2 minus a negative 4 is 2 plus 4. Use a calculator if you need to. You'll get 6. Square 6 and you'll get 36. Now here, use a calculator if you need to, guys. Negative 1 minus a negative 6. Just use a calculator. It gives you negative 1 plus 6, which is 5. And then 5 squared is 25. So there we go. And then add those together and you get the square root of 61. The square root of 61. Now some of you typed that in and had a decimal answer. That's totally fine. I don't mind that. That's totally fine. Whatever you want to do. Okay? No problem with that. All right, let's continue on to numbers 27 and 28. I've asked you to classify them as acute, obtuse, or right. And here's what I taught you to do, guys. I said to do L squared plus L squared, and then it's either going to be less than, greater than, or equal the hypotenuse squared. Now I know there's no really hypotenuse or leg, but you get the point, I believe. What I taught you is if there is a hypotenuse, it'll be the longest side. So the longest side always goes in for h. So that would be 14 squared. Okay? I think we need to do something here. I think it'd be very beneficial if I can actually find where I'm at here. I think we need a little more space, so bear with me, please, if you would. Okay, I can't do that, can I? Okay. Forget that idea. Let's continue on. It will not work. Okay, so I have my longest side goes in for h, and then my other two sides would be 10 and 12. They're my next two sides. Now, if you square 10, you get 100. If you square 12, you get 144. So 100 plus 144 is 244. Now, I think 14 times 14 is 196. I'm pretty sure that's right. So there we go, guys. I mean, look, wouldn't it be 244 is greater than? And what I taught you is whenever you square the legs and add them together and compare that to the hypotenuse squared, if this side is bigger over here, then that means you have an acute triangle. You just had to memorize that. It was right in your notes, okay? If this number here is bigger than this number here, then we have an acute triangle. Now we do the same thing over here. So we take our two smallest sides, 7 and 9, and we square them, add them together. And that's going to be greater than, less than, or equal to. And we take the longest side, which is 12, and we square it. So this really wasn't that hard if you just remember what to do. It's pretty much simple math. 7 times 7 is 49. 9 times 9 is 81. All right? Now add those together, and you will get 130 is less than 144. Now when that happens, when the square of your two smaller sides added together is less than the square of your longer side, then you have an obtuse triangle. You just had to memorize that, okay? If this side over here was less than, it's obtuse. Forgot my S there. Sorry about that. If this left side is greater than the right side, then it's acute. And then what if they were equal? Well, that's when you have a right triangle. If you would have got out 130 equals 130, then that means you have a right triangle. Okay? Now, is it possible to have a triangle with three sides measuring this? Well, what I taught you to do, students, was to find the two smallest sides and add them together. And when you do that, what you get out had better be greater than the other side. If not, then you cannot have a triangle. So your two smallest sides are 5 and 7. We can all see that. So we add the two smallest sides together. And when we do, we get out a 12. Now, is 12 greater than, what's my other side over here? A 12. Is 12 greater than 12? Not at all. No, 12 is equal to 12. 12 is not greater than 12. So is it possible to have a triangle with three sides measuring 5, 7, and 12? No, it is not possible. It's impossible. You will never have a triangle with measurements of 5, 7, and 12 for your three sides. It's not possible. And we know that, again, because what we do is we take our two smallest sides, add them together, and they had better be greater than, they had better be greater than the other third side. In this case, it was 12. All right? Okay, let's continue on now to number 30. Number 30, list the angles from smallest to largest. Students, this was not hard, guys. List the angles from smallest to largest. Now watch how we do this. Now what we learned in chapter 4 was this. The smallest angle is always across from the smallest side. So all you have to do is find the smallest side. Now, I'm not being mean, but it's not that hard. Where's the smallest side? Right here. So go straight across. A is your smallest angle. It says list the angles from smallest to largest. So I just found the smallest angle. Angle A. Now, what's the next smallest side? We've used 5. Next would be 6. So go straight across to the angle across. It's angle B. So angle B would be the next smallest angle. And the only angle left, guys, of course, obviously, is angle C. So we're going to put angle C. So A is the smallest, B is the next to smallest, C is the biggest angle. Now we're going to apply the same thing to number 31. Here I asked you to list the sides from longest to shortest, correct? Well, we learned that the longest side is across from the largest angle. The longest side is across from the largest angle. So if you want to list, I think I went A, B, C, or maybe I didn't put anything. I'm going to put A, B, C. If you use numbers for your sides, that was fine. Whatever you put, I didn't take off for that. You could have put anything you wanted, but you had to get the sides correct after you wrote something in. So I want you to list the sides from longest to shortest. So I want to find the longest side first, okay? Well, the longest side is always across from the biggest angle. So where's my biggest angle? Right here. That's my biggest angle. So go straight across. I see side AC. So side AC is my longest side. Now, sorry about that. Now, what's my next? Cross that angle off. Now, what's my next biggest angle? Not 42, it'd be 52. Now go straight across. That's side AB. So the next side, the side that's the next longest after AC is AB. Then the only side left we haven't used yet is BC. That's it. So students, it really wasn't too bad, okay? All right, now these here I thought were a little more difficult, but I thought I taught it pretty well, and I thought you guys got a hold of it pretty good. Here's the centroid in the triangle, P, okay? And I'm telling you KN is 24. So this whole line is 24, and that's called a median. We learned that. That line is called a median. And what I told you is, whenever you know the length of a whole median, always take the median and divide it by 3. Just divide it by 3. Always. Okay? Not 4, not 5, not 2, not 1, not 10, 3. Always take the whole median whenever you know what the whole median is. In this case, I told you KN, the whole median, not KP, not PN, KN, the whole median. I told you the whole median right here was 24. So we knew the whole median was 24, so we divide it by 3. And then what I told you is, whenever you divide by 3, the number you get out is always the length of the smaller segment on this whole median. Obviously, this is the smaller segment, so the 8 goes here. And the other segment's always twice as big. So if this is 8, this would be a 16. And by the way, that makes sense. Look, if this is 16 from K to P, and if from P to N it's 8, if you add those two together, don't you get 24? Sure you do. And the whole length is 24. So how long is KP right here? I'm looking for KP. How long is KP? 16. How long is PN? 8. Okay, let's take a look at this one. I'm telling you the length of PM. Now, would you look here at the screen, PM? I have a question for you. Is PM the whole median? No, the whole median would be JM. JM would be the whole median. I'm not giving you the whole median. In this problem, I'm just giving you part of the median. I am telling you that PM is 7. Now, is that not the shorter segment? Isn't PM shorter than JP? Sure it is. And what did I tell you in class and also over here? The shorter segment is always going to be half the size of the longer segment. Or in other words, the longer segment will be twice as big as the shorter. So if this little segment here is 7, then JP has to be 14. That's the longer segment. And so what's the whole length going to be? Well, we'll get to that in a second. So down here, I'm looking for JP. So let's go up here and look. JP is 14. JP is 14. So I'm going to go ahead and put 14. Now JM is the whole length, all the way down, the whole median. Well, if from here to here is 14, and from here to here is 7, add those two together, and the whole median is 21. Okay? All right. I hope this has helped, and I'm not at all discouraged or anything. I just want you all to really learn this, and I feel like it's very, for lack of a better word, it's very learnable, and I know you guys can do this math, okay? All right, call me or email if you have any questions, and we will go from there. Have a great day, and I will talk to you on Wednesday.